Sometimes you'll be sitting in math or science class, you'll be doing out a problem, and you'll look down and you'll say, how many digits am I supposed to report this answer to? Your calculator screen will have digits all the way from the left-hand side to the right-hand side, and you've got to figure out how many to write down in your paper. Well, the Atlantic Pacific rule for significant figures is going to provide the answer for that. Often in science, you're going to have to look at a set of numbers that come to you maybe via a story problem or maybe not. And you have to deem how many numbers are important enough to put in a final answer that you're going to turn into your teacher. So the Atlantic Pacific rule is going to help you decide that. You can see underneath my title there, I have sig digs and sig figs in parentheses. Now, what those are little shorthand versions of saying significant figures. Significant digits is what sig digs means. Significant figures has sig figs as the shortened version of it. Your teacher may use either one of them, but they're talking about the same thing. So there's going to be 3 steps to determine how many digits we deem important in a particular number. And let's start with step number 1. It says determine if the decimal point is present or absent. And all we have to do here is visually look at a number and determine whether there's a decimal point there or not. So in the case of the first number here, I definitely see the decimal point there. So I'm going to put a P, meaning present. 2,500. I do not see a decimal point, so I'm going to put A next to that one. 310,000.0, decimal point present. 700,001, no decimal point there. I'm going to put absent. And then 8.00 times 10 to the 6th power, decimal point right there. I'm going to put present again. Now, what's with all the P's and the A's? Well, the P's and the A's are going to link up with either the Pacific Ocean or the Atlantic Ocean. So if a decimal point is present, it has something to do with the Pacific Ocean and what you're going to do next. And if you have an A for decimal point not being there, A standing for absent, is going to link up with the Atlantic Ocean for a step you're going to do next with that as well. So let's take a look at our second step. I'm pretty sure we can all handle determining whether a decimal point is present or absent or not in a number. So here we go. If the decimal point is present, notice I underlined the P, you begin at the Pacific Ocean. Start at the Pacific side, the left side of the number, and move right until you hit your first non-zero digit. So in this case here, what they're saying to do is visually, with your eyes, start at the Pacific Ocean and move to the right until you hit your first non-zero digit. I'm going to stop right there because I see a 2 coming next. So this 2 and every digit to the right of it is considered significant. So that's 1, 2, 3, 4 sig figs. Okay. Our second one here, our number is 310,000.0. Again, because the decimal point is present, I start at the Pacific Ocean and move from left to right till I hit my first non-zero digit, which is not very far at all. It happens to be the 3. So this 3, and then every digit to the right is considered significant. That gives me 1, 2, 3, 4, 5, 6, 7 sig figs for that number. And my final example here, these originated on that first slide, the 8.00 times 10 to the 6th. This number right now is in scientific notation. And what we need to do is just pay attention to the number that comes before the time sign when you look at scientific notation. So again, Pacific Ocean here, move to the right, first non-zero digit is an 8. This 8 and everything to the right in the part that comes before the time sign is considered significant. And every time you see scientific notation in your book, whatever that comes, however many digits come before the time sign, they automatically do significant figures for you. So in this case here, there's 3 digits, 3 sig figs in this number. Okay, so this is the step where we're taking a look at numbers that have a decimal point in it. What if you get a number that doesn't? Well, if that happens, then we got to move on to step 3. If the decimal point is absent, we'll start at the Atlantic Ocean, so the A's match there. And if we're starting on the right-hand side of the number, we're going to move left, kind of the reverse of the sequence we did the last step. We're going to move left until we hit our first non-zero digit. that digit and everything to the left of it will be significant as well. So in a number like 2,500, I'm going to start at the Atlantic Ocean here. I'm going to move from right to left till I hit my first non-zero digit. That number is a 5. And this 5 and every digit to the left of it is significant. Now it's only 2 digits, but it's just showing as a model that if there were more digits here, those would be considered significant as well. So 2,500 then has 2 sig figs in that number. Okay, what about 700,001? In this number here, we move from right to left again. This 1 would be our first non-zero digit, and every digit to the left of it would be considered significant. So in this number here, we have 1, 2, 3, 4, 5, 6 sig figs, and we're all set. So again, calculating the number of significant figures, or I should say counting the number of significant figures, is going to be important for many of you, because when you write an answer on a paper, your teacher is going to expect that you know how to write the appropriate amount of digits that goes with your particular problem. Now, that being said, there are some rules for multiplication of two numbers and division of two numbers versus addition and subtraction. I'll put out another video in the near future that details that a little bit more. But for right now, just identifying the number of sig figs, I hope this helps. Keep studying, keep doing a lot of practice problems, and I'll see you next time.